Okay, let's do a mixture problem and talk about how to use matrices to solve it. So in this example, we have Miss Sandoval going into the homemade soap business. The lavender soap has 32% shea butter. The bergamot soap has 24% shea butter. And she wants to know how many ounces she should blend to obtain or have 54 ounces of lavender bergamot. So they're mixing together with 30% shea butter. Okay, so when we're going through this, make sure that you are identifying your variables, and your variables come from what they are asking you to find. They want to know how many ounces to obtain 54 ounces of lavender bergamot mix with 30% shea butter. Okay, so they want to know how many ounces do we need of each. They mentioned lavender first, so I'm going to make X equal to my ounces of lavender. And I'm going to have Y be my ounces of bergamot. I'm going to combine those two to get my 54 ounces with 30% shea butter. Okay, so I know there are a lot of words in here, but they're talking about two different things. They're talking about our soap mix, how much soap mix we want, and the percent of shea butter. So when we're doing mixture problems, we can actually make a chart, and that's going to help us keep our information organized. So I'm going to make a 3-row chart because they are talking about two different things that they're concerned about. And I know I'm going to need some header rows. Okay. So let's see. They are asking for two different things. They're asking about our ounces, and then they are asking about the shea butter, because we have two restrictions we have to meet. We need our ounces and we need a certain percent shea butter. Yeah. So with my columns, I know I'm going to have my lavender column because that's one of the things I'm mixing. And I'm just going to make a note that he is 32% shea butter. We're going to have our bergamot soap. And that guy was 24% shea butter. And then our last column is going to be our mixture column or our total. And we want to get to 30%. Okay. So from here, let's start filling in our chart. With our ounces of lavender, we don't know how many ounces of lavender we want. We said that was going to be our variable X. We don't know how many ounces of the bergamot soap we want. We said that would be Y. But we do know that we want a total of 54 ounces. And we just found our first equation. X plus Y is equal to 54. Now let's talk about that shea butter. It says that the lavender soap has 32% shea butter moisturizers. That means 32% of that soap is shea butter. Remember that of means times. So we're going to take our percent of our total. Remember, 32% as a decimal is 0.32, and of our ounces. So of means times our ounces, which is X for our lavender soap. For our bergamot soap, we have 24% of the bergamot soap is shea butter. 24%, move the decimal 2 places to the left, or take 24 divided by 100, you wind up with 0.24 of means times our bergamot amount, and we don't know how much that is. Remember, we called it y. And then for our total, our mixture, we know we want 30% of our total to be shea butter. 30%, so 30 divided by 100 gets us 0.30 or 0.3 of means times, and this time we didn't have a variable. We said we know we want to wind up with 54 ounces. When we take 0.30 times 54, we wind up getting 6.2, which means that we found our second equation. Same way when we combined with our ounces. So we're going to have 0.32x, which is in our lavender column in the shea butter row. We're adding that to 0.24y from the bergamot. We're going to set that equal to 16.2. And since we're using matrices to solve this, we are going to write the equation in AX equal to B form. So let's go ahead and do that. Remember, A is our coefficient matrix. Starting with my top equation, that'll become my top row. So I'm going to have 1, 1. And the bottom row is going to come from my second equation, 0.32 and 0.24. My X is my variable matrix, which remember, it goes vertically. It's going to be a 2 by 1 of X, Y. And that's going to be equal to matrix B. Matrix B is our constant matrix, or you can think it's our equal to matrix. In the top row, our first equation, we're equal to 54. And in the second equation, or second row, we're equal to 16.2. So now we've written it in AX equal to B form. To solve, remember that we need to take A inverse times B. So let's go ahead and find A inverse. So starting with A inverse. If you don't have the formula memorized, you're going to want to do that. We have 1 all over AD minus BC times our crazy matrix, where D and A flip-flop, and we negate on the backswing, just like we have the negative in the denominator. So plugging in, we're going to have 1 all over. Our little a was 1 times D, which is 0.24, this guy down there, minus B, which is again 1, times 0.32, which is our C. We're going to take that times our crazy matrix, where our main diagonal flip-flops. So 0.24 comes up, 1 goes down, and we negate on the backswing. We're going to have negative 0.32 in the bottom left and negative 1 in the top right. In the denominator of that fraction, we would have 0.24 minus 0.32, which gets us negative 0.08, which means we are going to have 1 all over negative 0.08 or 0.08, if that makes you feel better, times our crazy matrix. And we have multiplication by a scalar, which means that we are going to distribute this 1 all over negative 0.08 times 0.24. That crazy fraction times negative 1. Crazy fraction times negative 0.32. When you get your answers, go ahead and convert them back to simplified fractions. We should get negative 3 and then 25 over 2 in row 1, positive 4 and negative 25 over 2 in the bottom row. Now that we have A inverse, so that was the first step. We found A inverse. Now we can actually do the multiplication to solve the problem. So we said that X was equal to A inverse times B. We just found A inverse as negative 3. Oops. Adding in negatives when I shouldn't, sorry. So 4 in the first column, 25 over 2, and negative 25 over 2 in the second column. And that is a 2 by 2. We're going to multiply that by B, which was our constant matrix, our equal to matrix. And that is a 2 by 1. To double check that we can do this, the middle pieces are the same, and we're going to wind up with a 2 by 1 as a result. Since we're going to wind up with a 2 by 1, I'm not going to put in an X diagram. I am just going to make it with one singular bar around my matrix. We know that top is row 1 in the first column, and labeling the bottom would be second row, first column, and that tells us how to do the multiplication. Remember, RC cola. We're going to take our row times our column, RC cola. So we're going to take negative 3 times 54, because they both came first, plus 25 over 2 times 16.2, because they came second in our circled rows and columns. Now that we're done with row 1, column 1, let's go ahead and do row 2 times column 1. 4 and 54 both come first, so we're going to take 4 times 54. And we have plus a negative 25 over 2, or just minus 25 over 2 if you want, times our 16.2. And remember, the numbers right above each other should be the same in the parentheses. So my 54s are the same and my 16.2s are the same. It's a way to double check that you're doing the multiplication correctly. Okay. And then when we go ahead and solve this in our calculators, we get 40.5 up top, 13.5 in the bottom. Remember, you cannot stop here because they didn't ask for a matrix answer. They want to know how much lavender and how much bergamot soap they need to mix. But remember, our variable matrix, our X matrix, was equal to little x, little y, which means that X is 40.5 ounces of lavender. And then Y is 13.5 ounces of our bergamot soap. And if we mix those two amounts together, we'll wind up with our 54 ounces of 30% shea butter moisturizers. Take your time, watch your signs, and always make sure you explain your answer.